The question says that a ball is dropped from a height of 90 meter on a floor. At each collision with the floor, the ball loses 1/10 of its speed. Plot the speed time graph of its motion between time t equals to 0 to t equals to 12 seconds. So let us assume that this is the case. A ball is being dropped from here, which is 90 meter high. Once it is dropped, it rebounds with a velocity of 0.9 of the initial velocity, and again it is dropped, and again it rebounds to 0.9% of its last 0.9 times its last velocity. So we have to plot the speed time plot of this scenario. Now in a speed time plot, what we need to know is the speed it reaches when it goes to the ground, and the time that it takes for reaching the ground. So final velocity at the ground in the first instance can be calculated by relation v square equals u square plus 2as, where v stands for final velocity, u stands for initial velocity, a is the acceleration due to gravity, and s is the distance, that is 90 meter. So v would be equal to, since u equal to 0, so v would be equal to square root of 2 times 9.8 meter per second multiplied by 90 meter, and that would give us a v of 42 meter per second. And how much time it needed to reach there would be given by relation v equals to u plus at. Now we know that v final velocity is 42 meter per second, so substituting this in initial velocity is 0, so the acceleration is known. Now time would be equal to 42 divided by 9.8, and that would result out to be 4.3 seconds. So here velocity would be increasing from 0 to 42 meter per second, and in time interval of 4.2 seconds. So, and since the speed is going to be increasing, acceleration is constant, so the increase in speed would be a straight line, or it would be a uniform till 4.3 second. We have assumed downward direction as positive, so initial velocity is positive, but as we are only taking care of speed, so we are only considering magnitude over here, so it is always going to be positive. So it will reach to 42 meter per second in time interval of 4.3 second, and it will be plotted like this straight line. Now we will find out the time it requires to go to a second, go upward with a reduced velocity of 0.9 times this initial velocity. So the final velocity, the velocity after impact, is going to be v2 is going to be 0.9 times 42 meter per second, and that is 37.8 meter per second. And again acceleration of gravity is going to be 9.8 meter per second. So time interval it will take to reach zero velocity would be, since it is moving upward now, so it will reach zero velocity in some time interval, and that time interval can be calculated by using this relation. So 37.8 divided by 9.8 seconds would be equal to 3.9 seconds. So 3.9 second plus 4.3 would give us 8.2 seconds. Now this velocity will decrease to 37.8, and it will go down to 0 again in 8.2 seconds. Now again it will reach the ground level in time interval of 3.9 seconds. So, and the velocity would be again as that of the initial velocity at which it bounced, and that is of 37.8 meter per second. So at this level it is going to rise in again 3.9 seconds. So it would be 12.1 second. Velocity will rise to 37.8 meter per second. Now again the value will decrease to 0.9 times the initial velocity. So the final velocity is going to be equal to, after rebounding, it would be equal to 0.9 times 37.8 meter per second, and that is equals to 34.02 meter per second. So it will reduce to 34.02 meter per second. And the time interval that is required for it to become 0 when it bounces upwards is equals to 34.02 divided by 9.8, and that would be equal to 3.5 seconds. Since this goes beyond 12-second mark, so we don't need to plot any further, although we can plot successive iterations with this formula, using this formula. So this explains the falling down of the ball